This video is an introduction to bonding. Now you'll recall in the last chapter we talked about all those lovely periodic trends. For bonding, we're going to focus on one of those trends, which is electronegativity, or more specifically, the electronegativity difference. That is, the difference in electronegativity between the two atoms involved in the bond. Now in general, we're not going to actually figure out what the electronegativity is of two different elements and find that difference, though we could. But since we know the trends, we don't really have to. We know that if they're very close together on the periodic table, then the difference isn't going to be that much. And if they're farther apart on the periodic table, then the difference is going to be much larger. Let's think about what electronegativity is. Electronegativity, if you'll recall, is how easy it is for an atom to attract an electron. So think about a bond. Think about some atom, which I'm going to call atom A, and some other atom, which I'm going to call atom B. Now, bonding is about electrons. If atom A and atom B have a very small electronegativity difference, then the electrons don't really care whether they're over here with atom A or over here with atom B. And the electrons will be shared pretty much equally between these atoms. And I'm going to draw a line to represent that bond. And that's called a non-polar covalent bond. The electrons are being shared more or less equally between these two elements. Just to put a number on it, I'm going to say the electronegativity difference is less than, say, 0.4. Okay? If these two atoms are very, very close in electronegativity, if their difference is less than 0.4, that's a non-polar covalent bond. Right there. Now, as atoms get farther apart on the periodic table, their electronegativity difference gets larger and larger. And again, bonding is a continuum. It's not a cut and dry thing. The atoms don't actually say, oh, I'm done with being nonpolar, now I'm going to be something else. But it's about behavior. We're putting names to behaviors. So as this electronegativity difference between A and B gets larger, the electrons stop being shared equally. Let's say A here is more electronegative than B. If A is more electronegative, that means the A attracts the electrons more than B does. So the electrons start spending more time with A than they do with B. I'm going to rewrite this down here just so I have some more room. Now, if the electrons spend more time over here with A, that end of the molecule is going to have more of a negative charge associated with it than B does, because these negative electrons are spending more time over here. Now, we're still sharing electrons, okay? They still belong, quote unquote, to both, okay? This is still a covalent bond. But now, it's a polar covalent bond. This lovely Greek letter I'm drawing here is a lowercase delta, and it means a partial charge. So there is a partial negative at this end, and a partial positive at that end. And this has all kinds of consequences for behavior, which we will talk about. So again, I'm going to put a number on this just because I'm going to say between 0.4 and 1.7 That's where you're going to get the polar covalent bond. Now, once the electronegativity difference is much, much bigger, greater than 1.7, we'll say to put a number on it, there's no more sharing, okay? The electrons don't go back and forth along the bond. They stay with one element over the other. No more partial charges here. Now we've got an A that's actually negative and a B that's positive because B has lost its electron, one or more, to A. I have written one positive and one negative. But of course it could be two positives and two negatives, or three positives and three negatives, or some other whole number variation. But let's just keep it simple. What I've got here are ions. Ions. Charged particles. Charged particles. Now remember, electrons are negative. So something that is negative has gained electrons. And something that's positive has lost electrons. I know that's weird. I know we don't think of positive as being lost, but electrons are negative. So things that are positive have lost electrons and things that are negative have gained electrons. And now we have ions. This is no longer a covalent bond. This attraction between negative things and positive things is called an ionic bond. The attraction here is what's called electrostatic attraction. Electrostatic attraction. It means the positives and negatives attract each other. The strength of that attraction depends on radius. Oh, see, there was a reason we talked about trends. Because the closer they are together, up to a point, the stronger the attraction, and the farther away they are from each other, the weaker the attraction. And it depends on the strength of these charges. Are they +1, -1, or +2, -2, and so forth? So again, I say bonding is a continuum. Covalent bonds, sharing of electrons. Nonpolar covalent, very equal sharing. Polar covalent, unequal sharing. And then ionic, not sharing at all.